Hello students, myself Dr. Divya Gildial in continuation with my lecture series for AKTU Energy Science and Engineering for Btech second year students. Today I will be briefing you your unit 3 of solar energy. Please do subscribe to my channel as the subscribers will be getting one model paper 1 week before the final exam fully solved. Okay, let us begin. Solar energy. First, let us have a look at the syllabus. Obviously, the word solar will be coming from the word sun, and sun is the main cause of energy on everything on earth. Okay, so let us begin. What is the syllabus? Introduction to solar energy. In this, you will be briefed about how the sun's energy is responsible for all types of energies on earth, how green technology, greenhouse gases, solar energy, ultraviolet rays, etc. The fundamentals of solar radiation and its measurement aspect. This is something new for you. You should be having a basic knowledge of the basic angles that are involved in the construction of a building, an office, a house, or anything where the first demand of buyer comes is that sunlight should be proper at the residence, especially after the corona outbreak. So for that, the architect needs to have an idea of what will be the different measurement aspects he should take before going in for construction. So in fact, this is important. Basic physics of semiconductors. Why are you studying semiconductors in solar energy? You are studying semiconductors in solar energy because they are used in the solar panels, and solar panels have become very common, and they are used in all Indian villages and other places also, because what do? They store the sunlight during daytime, and then that stored sunlight is utilized at night, especially in places where power is a very big problem. So that is why semiconductor physics you should be familiar with. This is more of your intermediate course, so you can be comfortable with this heading of solar energy. You need to know about N-type, P-type semiconductor, junction diodes, what are the essential characteristics of depletion layer, etc. So once you are clear with semiconductor physics, you go into construct solar photovoltaic devices, which work only when solar energy falls on them. Okay, then the 3 generations of solar cells, the first, the second, and the third, which is more under research right now. Now, what is asked in your AKTU exam from this unit? From this unit, you are asked about semiconductors, you are asked about N-type, P-type semiconductors, semiconductor junctions. You are asked about direct and diffuse radiation of sunlight. You are asked to discuss in detail the 3 generations of solar cell. All this has been asked in your previous year question paper. So from according to that, I am briefing you what more can be asked by you in this year's examination paper. So let us begin. Let us first quickly look at the introduction to solar energy. Solar energy, obviously, the sun's energy, which is responsible for all types of energies on earth. You can also further categorize it as the energy obtained by capturing heat and light from the sun. Technology has provided a number of ways to utilize this trapped energy, and especially green technology, green building architecture, etc. all are based on solar energy. So solar energy is no doubt abundantly available, and it has been utilized both as a source of electricity and as a source of heating also. Solar technology is divided into 2 broad classifications. Active ones include photovoltaic systems, concentrated solar power and solar water heating to harness the energy. Active solar ones are directly consumed in activities such as drying clothes, warming of the air, etc. The passive ones include orienting a building to the sun, selecting materials with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. More detail of this is in your 4th unit, Green Building, Green Architecture, where you will be utilizing this knowledge of trapping solar energy in daytime and utilizing the same at night. Okay. Conversion of solar energy, obviously, you need to know the basics of how you will take this energy captured from the sun and convert it into electricity. Photovoltaic cells are very common methods which are used, and this is achieved by using semiconductor material. That is why you are studying semiconductor physics in solar energy. Okay. The process of converting solar energy into electricity so as to utilize its energy in day-to-day activities is absorption of energy carrying particle in sun's rays, photovoltaic conversion inside the solar cell, combination of current from several cells, conversion of direct current to alternating current. Okay, you must have heard about electromagnetic spectrum consisting of cosmic rays, X-rays, ultraviolet, visible, infrared. Today, you will get a brief idea of the solar spectrum. All this basic knowledge is necessary when you go ahead to design a building where the customer's demand is that I need sunlight at least in this part of my home, or for an office space designing, the basic requirement is sunlight at least in this much portion of my office. So for designing an architecture, necessary condition is that you should know about solar spectrum and you should know about the few measuring angle aspect. So solar intensity outside the atmosphere is 1.36 kilowatt per meter square. This is used in numericals, but it will be given to you in the question. Incident solar intensity in the atmosphere due to absorption by water vapor, carbon dioxide, pollution particles, etc. It reduces. Radiation reaching the Earth's surface by direct radiation and diffuse radiation. This question was asked in AKTU. You have it here in your syllabus also. And how much it gets diffused due to, see, sunlight directly does not reach the Earth without getting any type of interference. Earth is surrounded by troposphere, stratosphere, ionosphere. Sunlight has to pass through all these things before reaching the Earth. Pollution, clouds, dispersing particles, etc. So what happens is that the sunlight and the beginning of the atmosphere is very strong. Slowly, by the time it reaches the Earth, it either gets absorbed, diffracted, dispersed, etc. And you don't get exactly the full amount of solar light. Fundamentals of solar radiation and its measurement aspects. This should be clear before you go ahead to design a green building or a green architecture. More detail of all this is in your higher semester. Here you just need to know the few angles and their definition. That's all, not much detail. Solar geometry, that is the Earth's daily rotation about its axis and its revolution around the sun. They are all responsible for different seasons of the year and day and night of the Earth. So what happens is that the Earth passes alternatively above and below one plane, making one complete elliptic cycle every year. So you are familiar with the word incident angle. You have heard it in optics that Incident angle is the angle between the where the light gets incidence and if I draw a normal. So exactly this way we say that when sunlight drops at a glancing angle or uh, at an angle, then a normal drawn to it gives me the incident angle. This is the beginning of any optical phenomena. Thin film interference, dispersion, diffraction, interference, anything. First thing is you should be knowing the angle of incidence. Latitude angle, obviously you should be knowing about it before you go ahead to design anything based on solar architecture, and this is a very big demand in today's world. Every demand that comes from the customer, necessary requirement is sunlight in the office, in the house, or anywhere where they are going in for a construction project. So it is the angle subtended by the radial line joining the place to the center of the earth with the projection of the line on the equatorial plane. This is my sunlight. See here, it is getting incident, angle of incidence I have already told you. The solar altitude, the solar azimuthal angle, this is the angle, the latitude angle here. Okay, next. Declination angle. You must have heard in magnetism, angle of dip and angle of declination. Here, declination is the angle made by the line joining the centers of the sun and earth with its projection on the equatorial plane. Equator. Why equator? Because earth is rotating on its own axis and it is inclined at an angle on the axis. It is not standing perpendicular. Our angle, it is the angle through which the earth must be rotated to bring the meridian of a point directly in line with the sun's rays. All these things have to be kept in mind, that sunlight during daytime, what the condition will be, what it will be during sunset, what it will be in the morning. Altitude angle, it is vertical angle between the projection of the sun's rays on the horizontal plane and the direction of the sun's rays. The altitude is angle is maximum at solar noon. This you must be familiar because in the afternoon it is not possible to go and directly stand in front of sunlight. Zenith angle, it is the vertical angle between the sun's rays and line perpendicular to the horizontal plane through the point. Surface azimuthal angle, for tilted surface azimuthal angle, angle of deviation of the normal to the surface from the local meridian. It is the angle between the normal to the surface and south. For south facing, azimuthal angle is 0. For west facing, it is 90 degree. There are many more solar basic concepts. You just need to know the basic solar angles, that is latitude of location, declination, hour angle, the derived solar angles, that is altitude angle, zenith angle, and solar azimuthal angle. Now, solar constant. Measurements indicate that the energy flux. What is flux? Number of lines passing through any area, surface area. You have heard it in Gauss law of magnetostatics and electrostatics, flux. Now in this case, it becomes energy flux. So rate of energy transfer through a unit area received from the sun outside the Earth's atmosphere is approximately a constant, and the rate at which energy is received from the sun on a unit area perpendicular to the rays of sun at a mean distance of the earth from the sun is approximately 1367 watt per meter square. This obviously, if it's a multiple choice question, you are appearing in some competitive exam, then this can be asked in your AKTU paper. Section A, they can ask, define solar constant and give its numerical value. Solar radiations, often called the solar resource, is a general term for the electromagnetic radiation emitted by the sun. Solar radiations can be captured and turned into useful forms of energy, such as heat and electricity, using variety of technologies that have come up in the near future. Also, there are many more technologies that are coming up, which are becoming a very good source of alternative for electricity. Okay. Now, if suppose amount of solar radiation that will be reaching my study point, I need to see, will vary according to the basic following parameters. See, we are not right now considering the natural calamities, heavy rain, thunderstorm, or etc. General, I need to know the geographic location. If it is at the poles, then sunlight will be very less. If it is at the equator, sunlight on its own is going to be more. Time of the day, at night there is no sunlight, so I know my solar panel will not be functioning at night. I know my photovoltaic cell will not work at night. Season of the year, in winters there is a shortage of sunlight because it gets surrounded by clouds, etc. Local landscape, it depends a lot. If you are doing the experiment in deserts, if you are doing it in a snowy place, you are doing it near the seaside. Local weather is also very important. If it is raining whole day, then what is the use? Where will you capture sunlight and use it at night? So these are certain basic requirements. Now, for your exam point of view, you might be asked, discuss in general the various points to be kept in mind before designing a solar panel, or before deciding the amount of solar radiation that is going to reach the Earth's surface. This is a theoretical paper, and you have to write the answers in your own words in English. So there is no set and defined answer for a question. So in general, you should be just having basic idea, like when the sun's rays are vertical, the Earth's surface is going to get all the possible energy. The moment they become slanted, the longer they travel through the atmosphere, they become scattered and diffused, and then you get lesser energy reaching the Earth. Earth is revolving around the sun in elliptic orbit, and at times it comes very close to the Earth during certain parts of the year, and at times it is further away from the Earth. The tilting of the Earth on its own axis, and then because of rotation of Earth, the hourly variations are also to be kept in mind. Now, devices that are used in measuring the solar radiation, this is important. This is important, and I think one device has been asked in your previous year paper. It was for a 10-mark question. I will explain you both the devices. They are the common ones, and these two are in your syllabus also. Pyranometer is a sensor which is converting the global solar radiation it receives into an electric signal which can be measured. See, pyranometers are measuring a portion of the solar spectrum, and it is based on Seebeck or thermoelectric effect. Main components are a black absorber, a thermopile, a pyranometer body, and additional basic electronic instruments. Look at this diagram of pyranometer. Along with me, you can just write what every part is doing. See, pyranometer is different from other devices because it has this dome shape. Why is this dome shape very useful in solar physics? Because what happens is that this shape helps me in collecting maximum number of solar radiations. And the more I put the layers on it, filtered layers, what happens is that they absorb all the pollution particles, they absorb whatever layers I do not require, and the filtered ones are reaching my apparatus. See, the dome is in English means this circular portion, semicircle, on a pyrometer is acting as a filter that transmits solar radiation with wavelengths as per my requirement. Usually, the general range of wavelength here is 0.3 to 3 into 10 to the power of -6 meter. This much it does the filtering work. It is just like home filters you must have seen, and blocks thermal radiations with wavelength longer than this. And after that, what it does is pyrometer domes are specially made from Scott and BK7 glass or some other varied form of glass, or fused silica also can be used. And the transmission of solar radiation through a dome is ideally close to 100%. But in practice, you know, in science, nothing is 100%. Some percentage error will be there. So I approximate it to by saying that if 100% solar radiation is falling on this on a very hot day, 92% will only reach here. This dome is also serving to me as to black absorber and the thermopile which I have kept here from natural calamities like rain, snow, thunderstorm, etc. Suppose I carry this pyrometer to a place and suddenly snowfall happens. Then the snowfall can, damage my apparatus. So this dome is going to protect it. So that is why the pyrometer in itself stands different from other apparatus because of this dome shape, and because of this only its cost becomes high. Okay, the filtered radiation absorbed get converted into heat, and if transmission through the dome is represented by tau, area of the black surface is capital A, and absorption coefficient of the black surface is alpha, then the heat absorption is calculated as alpha tau A into the amount of energy. This creates a temperature gradient from the black surface through the thermopile to the pyrometer body, which acts as a heat sink. And this heat thermopile consists of a number of thermocouples that are connected in series. Each thermocouple will generate voltage proportional to the temperature difference between the black body and surface and body, and it can be utilized for my purpose. So whatever purpose, if it is my measurement purpose, because voltage has been created. See, it is generating a voltage proportional to the temperature difference. My work is done. Now I can use it for my practical applications. Now, pyrometer is a dome-like structure that measures diffused sun energy, while pyrheliometer is an instrument that measures direct sun's energy. Pyrheliometer, it is a device used for measuring the beam of direct radiation. Look here, in this diagram, there were other types of diffused radiations also falling on it. Direct and diffused radiation question is very important. I will continue in the next lecture. I will show you the whole comparison. Let me quickly finish pyrheliometer. The tube is made to face the sun's radiation. See, direct rays are falling here. Can you see? Direct. And thereby receiving only the beam radiation, and no diffuse radiation can enter this tube. And this is a very good point, because direct radiations will be carrying large amount of heat. Diffused ones will have less heat because diffused ones have not come through a direct source. And then when these radiations fall on the absorber plate, it absorbs the radiation and it gets heated up, thereby temperature rises. This rise in temperature is measured by the thermo EMF of the thermopile here. And you measure this rise in temperature. Okay, next lecture, diffuse and direct radiation. Please don't forget to subscribe my channel. Thank you.